Welcome to Astronomy Daily, your go-to source for the latest discoveries and developments in space science. I'm Anna, and joining me, as always, is my co-host, Avery. Today, we've got some absolutely fascinating stories to share with you.
Hey everyone, Avery here. And Anna, you're not kidding about fascinating. We're talking about what might be the best evidence yet for life on Mars, some surprising risks with asteroid deflection missions, and NASA is getting creative with helicopter training in the mountains. Plus, the Pentagon just launched a bunch of satellites that could change missile defense forever.
Right? It's like science fiction becoming science fact. Let's dive right into our biggest story today. The Perseverance rover has been busy on Mars, and the data it's sending back is absolutely mind-blowing. We might be looking at the strongest evidence yet for microbial life on the red planet.
Okay, so tell me about these leopard spots, Anna, because when I first heard about this story, I thought someone was pulling my leg. Leopard spots on Mars?
I know, it sounds wild, but that's exactly what scientists are calling these speckled patterns on a rock called Shivaya Falls in the Bright Jingle Formation. And here's where it gets really interesting. These aren't just pretty patterns. The spots contain organic, carbon-rich material, which is already exciting, but there's so much more.
More? Lay it on me. What else did Perseverance find in these spots?
Well, they found clay minerals, which tells us water was definitely present when this rock formed. Then there's calcium sulfate, iron phosphate, and here's the kicker: iron sulfide minerals, probably vivianite and greigite. These specific minerals are really important because they suggest biological processes similar to what we see with Earth microbes that literally breathe rust and sulfate.
Wait, microbes that breathe rust. That sounds like something out of a superhero movie. How does that even work?
It's actually pretty amazing. These microbes use iron and sulfate compounds instead of oxygen for their metabolism. They basically eat the rust and sulfate to survive. And the mineral signatures we're seeing on Mars are exactly what you'd expect to find as waste products from this kind of biological activity.
Okay, but I have to ask the skeptical question here. Could there be non-biological explanations for these patterns and minerals?
That's exactly the right question to ask, and scientists have considered that. Non-biological processes could theoretically create these minerals, but they would require extreme conditions. We're talking temperatures between 150 and 200 degrees Celsius or extremely high acidity. The problem is, when researchers analyzed the rocks, they found no evidence of these extreme conditions ever being present.
So we're left with biology as the most likely explanation, but we're not popping champagne just yet, right? What's the next step?
Exactly. The samples need to be returned to Earth for definitive analysis. We need the full power of Earth-based laboratories to really confirm what we're seeing. That's where missions like Mars Sample Return become absolutely crucial. We're potentially looking at one of the most significant scientific discoveries in human history, but we need those samples back home to be sure.
Speaking of things that could go wrong, our next story is a real eye-opener about asteroid deflection missions. Turns out, trying to save Earth from an asteroid impact might accidentally put us in more danger if we're not extremely careful.
This story really got my attention because it sounds counterintuitive. How can protecting Earth from an asteroid make things worse?
It all comes down to something called gravitational keyholes. These are specific areas in space where a planet's gravity can alter an asteroid's trajectory in unexpected ways. Researcher Rahil Makadia and his team, building on results from the DART mission, discovered that if you hit an asteroid in the wrong spot or at the wrong angle, you could accidentally steer it through one of these keyholes.
And then the planet's gravity takes over and potentially sends the asteroid on a collision course with Earth. That's terrifying. How do we avoid this?
The solution is really sophisticated planning. Makadia's team has created what they call probability maps that show where asteroids are most likely to go after being deflected. They have to consider everything: the asteroid's shape, how fast it's rotating, its mass, even the topology of its surface. Every asteroid is different, so each one requires its own detailed analysis to find the safest impact zones.
It's like cosmic billiards, but with the fate of humanity hanging in the balance. This research really shows how complex space missions can be. You can't just point a spacecraft at an asteroid and hope for the best.
Exactly. And it makes the DART mission results even more valuable because now we have real-world data about how these impacts actually work. Speaking of impressive space discoveries, let's talk about what the Webb telescope has been up to lately. Anna, this stellar jet story is pretty incredible.
Oh, wow, yes. Webb captured images of this absolutely massive stellar jet and the Sharpless 2-284 nebula. We're talking about a jet that's 8 light years long. To put that in perspective, that's almost twice the distance from our sun to the nearest star, Proxima Centauri.
8 light years long, that's mind-boggling. What's creating this massive jet?
It's streaming from a protostar, basically a baby star that's still forming, and this particular protostar weighs about 10 times more than our sun. The whole system is located about 15,000 light years away from us. What makes this discovery so special is that most protostellar jets we've observed before came from much smaller, low-mass stars.
So this is giving us insights into how massive stars form, which is still pretty mysterious, right?
Absolutely. And there's another fascinating aspect. This discovery provides evidence that jets scale with stellar mass. Bigger star, bigger jet. Plus, it's giving us insights into massive star formation in low metallicity environments, which are similar to conditions in the early universe. It's like getting a window into how the first massive stars formed billions of years ago.
From massive stars to missile defense, our next story takes us back down to Earth. Well, sort of. The Pentagon just launched 21 satellites as part of a new missile defense constellation. Anna, this sounds like something out of a Tom Clancy novel.
It really does. They're calling it the Proliferated Warfighter Space Architecture, and these 21 satellites are just the beginning. The plan is to build 154 operational satellites over the next 9 months. But here's what's really interesting. They're completely changing the economics of military satellite.
How so? I imagine military satellites are pretty expensive.
Traditional military satellites in geosynchronous orbit cost over $1 billion each. These new ones, 14 to 15 million each. That's a massive cost reduction. They're operating in low Earth orbit instead of the much higher geosynchronous orbits, and they're designed to work as a network rather than individual super expensive satellites.
So it's quantity over individual capability. What will these satellites actually do?
They'll provide beyond line of sight communications using Link 16 tactical data networks, which is military communication standard. But more importantly, they're designed to detect modern threats like hypersonic weapons, which are notoriously difficult to track with traditional systems because of their speed and unpredictable flight paths.
That makes sense. Having a distributed network of cheaper satellites means you're less vulnerable if you lose one or two. And finally, let's talk about NASA getting creative with astronaut training. Are they using helicopters in the Colorado mountains?
This is such a clever training approach. NASA just certified a new helicopter flight training course in the Colorado mountains, specifically designed to simulate lunar landing conditions for the Artemis missions. Astronauts Mark Vande Hei and Matthew Dominic were part of this certification process.
I'm trying to picture this. How do mountains in Colorado simulate the moon?
Great question. The mountainous terrain creates similar visual illusions to what astronauts will experience when landing on the moon. Without familiar reference points, it becomes really challenging to judge distances and altitudes accurately. Plus, the dusty conditions in some areas help simulate how lunar dust will interact with the lander's thrusters, which is actually a major concern for lunar missions.
Right, because lunar dust is extremely fine and gets kicked up by the rocket exhaust, which can create a total whiteout during landing. This real-world flight training sounds way better than just using simulators.
Exactly. And it's not just about individual piloting skills. The training focuses heavily on crew coordination and communication, which will be absolutely critical when they're trying to land on the moon. There's no room for miscommunication when you're piloting a lunar lander to the surface.
It's amazing how NASA keeps finding innovative ways to prepare for these missions. From potential life on Mars to asteroid deflection challenges, from massive stellar jets to military satellites and lunar landing training, what a week for space news.
It really has been incredible. And I think what strikes me most is how all these stories show us that space exploration is this perfect blend of cutting edge science, careful planning, and sometimes creative problem solving. Whether we're looking for life on Mars or training astronauts in Colorado mountains, it's all about pushing the boundaries of what's possible.
Couldn't agree more, Anna. That's all for today's episode of Astronomy Daily. Thanks for joining us on this journey through the latest space discoveries and developments.
Keep looking up, everyone. The universe has so much more to show us. Until next time, this is Anna and Avery signing off from Astronomy Daily.
Actually, Anna, before we wrap up, I wanted to touch on one more fascinating story that came across our desk this week. The European Space Agency just announced some remarkable findings from their Gaia mission about stellar nurseries in our galaxy. It's really changing how we understand star formation.
Oh, yes. The Gaia data is incredible. They've been mapping the positions and movements of over 1 billion stars. And what they're finding about stellar associations and how stars form in clusters is really rewriting the textbooks. Tell our listeners what makes this discovery so special.
So what Gaia has revealed is that star formation is much more complex and interconnected than we previously thought. They've identified these massive stellar streams, groups of stars that were born together and are still moving through space together, even millions of years after their formation. Some of these streams stretch for hundreds of light years across our galaxy.
That's mind-blowing when you think about it. Our sun could have siblings scattered across the galaxy that we're just now discovering. But what does this tell us about how star formation actually works? I mean, this seems to challenge the idea that stars just form randomly throughout space.
Exactly. It's showing us that star formation happens in these cascade events. When one massive star explodes as a supernova, it triggers star formation in nearby gas clouds, which can then trigger more star formation, and so on. It's like cosmic dominoes. And here's the really cool part. By tracing these stellar streams backward in time, astronomers can actually map out the history of star formation in different regions of our galaxy.
It's like having a time machine for galactic archaeology. And this connects beautifully to our earlier discussion about that massive stellar jet Webb observed. We're seeing the universe as this incredibly interconnected system where everything influences everything else across vast distances and timescales.
Speaking of interconnected systems, Anna, I also wanted to mention the latest updates from the Artemis program. NASA just released some new details about the Gateway Lunar Space Station and how it's going to serve as a staging point, not just for moon missions, but potentially as a refueling stop for missions to Mars. The engineering behind this is absolutely fascinating.
Yes, the gateway concept is brilliant because it's essentially creating a permanent human presence in lunar orbit. What's really exciting is how they're planning to use in situ resource utilization, basically mining water ice from the moon's south pole to create rocket fuel. This could make Mars missions exponentially more cost effective because you wouldn't have to carry all your fuel from Earth.
Right, because escaping Earth's gravity well is so energy intensive. If you can refuel at the moon, you're essentially getting a head start toward Mars. And the international cooperation aspect is really encouraging too. We've got contributions from Canada, Europe, Japan, and other partners. It feels like we're building the infrastructure for humanity's expansion into the solar system.
And speaking of international cooperation, I have to mention the incredible success we're seeing with commercial space companies. Just this month, SpaceX conducted their most ambitious Starship test yet. And we're seeing companies like Blue Origin and others really pushing the boundaries of what's possible. The cost of getting to space continues to plummet, which opens up so many possibilities for scientific research.
Anna, what an incredible journey we've taken our listeners on today, from the potential discovery of ancient life on Mars to the cutting-edge engineering that's making space more accessible than ever before. It really shows how rapidly our understanding of the universe is expanding.
Absolutely, Avery. And I think what's most exciting is that we're not just passive observers anymore. We're actively participating in this exploration, whether through robotic missions, human spaceflight, or the incredible engineering achievements that are making it all possible. The future of space exploration has never looked brighter.
Well said, Anna. That's a wrap for today's extended episode of Astronomy Daily. Thanks for joining us on this comprehensive look at the latest in space science and exploration. Until next time, keep looking up.